Okay, question 3. A soccer ball is kicked from ground level with an initial velocity. Alright, so let's get ground level. So here's green for ground, and it's given an initial velocity, so here's the soccer ball, and it's going to be kicked at some angle, and this initial velocity is 23 meters per second, and this angle is 40 degrees above the horizontal, and envision it being kicked downfield from left to right, so right and up are plus, so up is plus and to the right is plus. Alrighty, and use 10 for G, so G is 10 meters per second squared, and that means it's negative because up is plus, so down is negative, and we want to round everything to 1 decimal place. The initial horizontal velocity, okay, so the initial horizontal velocity is going to be this component, is V0 cosine theta, that's the initial horizontal, which is 23 times the cosine of 40, which is 17.6 meters per second. And the initial y velocity goes this way, so the initial y velocity is V0 sine theta, so that's 23 times the sine of 40, which gives me 14.78, so that's going to be 14.8 meters per second. Okay. Oh, I left out the horizontal and vertical accelerations. The horizontal acceleration is 0 meters per second squared, because it's not accelerating horizontally, and the vertical acceleration is negative 10.0 meters per second squared. All right. What's the time to the top of its path? So basically, let's do a little mini drawing here. It starts here, and it goes up, and it comes back down. So at the very top here, it's key to know that the y velocity is 0 at the top, not the x. The x is still 17.6 meters per second, because that doesn't change. So at the top, it has horizontal but no vertical velocity. So I can use this fact to figure out how long it takes to get to the top of its path. So I would use the equation v final, so that final velocity right there equals v initial plus at, so the v final is 0 meters per second. The initial is 14.8 meters per second plus negative 10.0 times t. So solving for this, we end up with t equals 1.48, which rounding to 1 decimal place gives me 1.5 seconds. So if I'm going to 1 decimal place, that's the answer there. Okay. Next, what's the ball's maximum height? Well, I've got a couple of ways I could do this. One is using our equation that says v final squared equals v initial in the y direction squared plus 2 times the acceleration times the displacement, which this right here, this value is our height, maximum height. And we have already established that at the top vertically, this is all vertical by the way, at the top vertically is 0. This is the initial 14.8 meters per second, and a is negative 10. So just solving for delta y first, delta y equals v final squared minus v initial squared divided by 2a. So that gives me 0 squared minus 14.8 squared divided by 2 times negative 10. So that displacement is basically, these are negative divided by negative, so it's 14.8 squared divided by 20, which gives me 10 point, so the answer is 10.952, which rounded to the nearest tenth bumps me to 11 meters. So that's my height. That's delta y, the height. Okay, 11 meters. The total time in the air is 2 times the time to the height because it's landing at the same height as it is being kicked. So total time is going to be 3 seconds because it's 2 times 1.5. Let's see here, the ball's range, so the horizontal distance. So let me pull up another bit of paper here. So the horizontal distance, all this scrap paper. Okay, you see I reuse paper. So the horizontal distance, delta x, is equal to the horizontal velocity times the time to get there. So this is that horizontal velocity of 17.6 meters per second times the total time that we just figured was 3 seconds. So 17.6 times 3 is 52.8 meters. And the ball's velocity at time t equal 1.2. All right. So at t equal 1.2, I know that the x component is the constant 17.6 meters per second. What I need to find out is what's the y velocity at time 1.2. So I'm going to use the equation final velocity in the y direction equals the initial velocity in the y direction plus the acceleration times the time. And this is what I'm going to get with 1.2. And my initial y velocity was 14.8 meters per second plus this is negative 10 meters per second squared times 1.2. So that's 14.8 minus 12, right? So minus 10 times 1.2 gives us 2.8. So that's 2.8 meters per second, but it's still positive. So it's still going upward, which makes sense because it took 1.5 seconds to get to the top. So it's still on its way up, so this is positive. So the actual magnitude of the velocity at 1.2 seconds is equal to the square root of the x component squared plus the y component squared, which is the square root of 17.6 squared plus 2.8 squared, and that's going to be square root 17.6 squared plus 2.8 squared, and that's going to come out to be 17.821, so it's going to be 17.8 meters per second rounded to the nearest tenth. And then the angle, well, theta is the inverse tangent of the y component divided by the x component, and they're both positive. So that'll be the inverse tangent of 2.8 over 17.6. So inverse tangent 2.8 divided by 17.6 gives me 9.039 or 9.0 degrees rounded to the nearest one.